So in this video I'm going to talk about the magnetic field from a long straight wire, and this is covered in chapter 30-3 of the textbook. Okay, so what we saw in the first video, well, I told you at least that the source of magnetic field is actually moving charges. So the story goes that Hans Christian Ørsted, who was a physics professor in Denmark, if I do remember correctly. So basically the story goes that he had a rather messy classroom and he was doing some sort of a demonstration with electric current, and he happened to have some compasses in his messy classroom close by to these wires, and he noticed that when he turned the current on in the wires, it caused the compass needles to deflect, and this was in 1820. So this is really the first time that people realized that moving charged particles, so currents, are really the source of magnetic fields. So up until this point, people didn't understand the connection, because after all, the sorts of like magnetism, which is, like magnetics and lodestones and, naturally occurring magnets, you might think are very different than like electric charges. And for a long time, people didn't see that there was a connection between them. Now, so the magnetic field, so if you have a long straight wire, so the picture on the right here shows that the magnetic field lines from a long straight wire are just concentric circles, that go around the wire. So, and remember what we saw in the first time, so magnetic field lines, so they are always closed loops, so they never start and stop. So these are circles, so yes, they are closed loops and they don't start or stop. So the direction of these things is given by the right-hand rule. So if you have a wire, and let's say the current is going up, so you take your thumb, point that in the direction of the current, and then your fingers will wrap around, will point in the direction of the field lines. So you can see here, so the current is up, so the field lines wrap around in that direction. So the field strength, of course, is going to be proportional to the current. So the more current, the stronger the field is going to be. And it's inversely proportional to the distance from the wire. So the further you are away from the wire, the weaker the field is. And of course, the usual things with superposition still works. If we have several wires, we can find the total magnetic field is just the sum as the magnetic field from the individual wires.